Okay, so good morning. Um, Now we will now proceed with our next topic in module number 3, which is atoms and its related concepts. So at the end of this topic, you are expected to explain the different atomic modules. Okay? Determine the atomic mass and atomic number, and discuss the different parts of the atom. So the key questions in studying about the atoms and its related concepts are: why are atomic models important? Why did technological advancement pave the way? Or how did, rather, technological advancement pave the way for modifying the atomic models? So as an overview, atoms are extremely small with diameters of about many billions of an inch, which make it possible to be seen with the naked eye. So within the advancement of this invention, which is what we call the STM or scanning tunneling microscope, we can sophisticatedly see, okay, what is the possible outlook of an atom. Okay? So, the nucleus, being the center of the atom, contains the protons, which is positively charged, the neutrons, which has no charge, and its outer region of the atom is called the electron shells, or it contains the electrons with negatively charged. Okay. So the Greek philosopher Democritus introduced the idea of the atom. Again, Democritus is a Greek philosopher who first gave an idea about the atom. However, the idea was essentially forgotten for more than 2,000 years in 1800s. So, John Dalton reintroduced the atom. In Greek, the prefix "a" means not, and the word "tomos" means out, or means cut, rather. Okay? Our word atom therefore comes to atomos, which means uncuttable or indivisible. So here are the different timelines or a brief history of matter and atoms. In year 450 BC, Empedocles asserted that all things are composed of four primal elements, which are the earth, air, fire, and water. And in 400 BC naman, Democritus proposed that all matter is made up of a very small particles called atom, which cannot be divided into smaller units. While in 380 to 320 BC, Aristotle proposed that all matter was continuous and be further divided definitely into smaller pieces. So there is a contradiction between this history. Okay? Now, in 1799, Joseph Ross proposed the law of definite proportions, while in 1808, John Dalton promoted the atomic theory and proposed the law of multiple proportions. In 1869, Dmitry Mendeleev, arranged the known elements in a periodic table based on atomic mass, while in 1890s, Anton Becquerel and Marie Curie, observed that radioactivity causes some atoms to break down spontaneously. In 1895, Wilhelm Röntgen discovered the X-rays, and in 1897, Joseph John Thomson discovered the electrons. In 1904, J.J. Thomson suggested the plum pudding model of the atom, which shows that electrons move in concentric orbits around the nucleus. And 1908 to 1917, Robert Millikan found that the charge of an electron is equal to 1.6022 times 10 raised to negative 19 coulombs. In 1910 to 1911, Ernest Rutherford observed that atoms are mostly empty space, while in 1913, Niels Bohr proposed an atomic model that shows electrons move in concentric orbit around the nucleus. So, Henry Gwain, Jeffrey Moseley used X-ray spectra to study the atomic structure during that time. And in 1919, Ernest Rutherford also discovered the positively charged, which is what we call now protons. And 1932 naman, it was James Chadwick who discovered the electrons. Okay. So, let us now proceed with these different atomic models. Okay. So, una natin pag-aaralan is about Dalton's atomic model in 1808. Okay? So, number one, each chemical element, according to his atomic model, each chemical element is composed of extremely small particles that are invisible or indivisible. When we say indivisible, it means uncuttable and cannot be seen by the naked eye. Okay? And that is what we call atoms. All atoms of an element are alike in mass and other properties, but the atoms of one element differ from all other elements. So just like for example, yung gold at saka yung silver, it has its different atomic masses and different properties. Okay? Sa kulay pa lang, no? Sa properties pa lang niya at saka sa mass niya, different na sila. Then, for number 3, for each compound, different elements combine in a simple numerical ratio. And another one is in a chemical reaction, atoms are neither created nor destroyed, and they simply combine, separate, and rearrange. So, from Dalton's atomic model, here are the other atomic models na meron tayo. No? Number one nito is the plum pudding model of the atom. Okay? So, this is the time when the electron was discovered. It was in the year 1898 to 1903. So, after J.J. Thomson discovered the electron in the cathode rays, he proposed that the plum pudding model of the atom, which states that the electron float in positively charged material. So this model was named after the plum pudding dessert. However, it was George Stoney who first gave the term electrons to the cathode rays. So the plum pudding model is defined by electrons which is surrounded, as you can see here, which is surrounded by a volume of positive charge. Okay? Like negatively charged plums, which is embedded in a positively charged. Okay? So, to be compared in pudding. Diba? So, the pudding is, kung makaobserbahan ninyo, is yung tinapay niya. Tapos may mga puti-puti siya sa gitna, di ba? Yung parang nabuong harina. So, parang ganun ang itsura niya. No? Parang blueberry muffin. Di ba? The blueberry muffin, yung pinakang bread niya is kulay violet. Tama? While yung berries naman is nasa gitna. Yun yung parang negative electrons. While yung pinakang tinapay or the ball, it is a positively charged. Okay? Or a positive charge. Okay? So, yun yung plum pudding model of the atom which was discovered in 1898 to 19. So, let us now proceed with Ernest Rutherford's model. Ernest Rutherford's model, which has been discovered in 1911. It was actually the discovery of a proton. Okay? So, as you can see here in the illustration, no? Here is how he discovered his atomic model. Okay? So, the physicist Ernest Rutherford envisioned the atom as a mini miniature solar system, with electrons orbiting around the massive nucleus and as mostly empty space, with nucleus occupying only a very small, as you can see here, a very small part of the atom. So the neutron had not been discovered when Rutherford proposed his model, which performed a series of experiments or had the nucleus consisting only protons. So in 1809, Ernest Rutherford performed a series of experiments by shooting a beam of alpha particles, as you can see here, a beam of alpha particles or a positively charged at a thin piece of gold foil. Yun yung gold foil yung nasa gitna. Okay? So Rutherford observed that the majority of the alpha particles went through the foil. However, some particles were slightly deflected. So a small number was greatly, okay, a small number were greatly deflected and another small number were thrown back in a nearly nearly the direction from which they had gone. So in other words, Rutherford's model shows that an atom is mostly empty space, with electrons that is orbiting a fixed, positively charged nucleus in the center. So this model states that there were positive particles within the nucleus, but failed to define what these particles are. So meaning to say, that time, na-discover na pala si proton, pero hindi pa siya definite. Okay? It is not actually definitely that it was called as a proton. Okay? So let us now proceed with atomic number or atomic model number 3, which is the Bose atomic or Bohr's atomic model. It was discovered in 1913. Okay? So in 1913, Bohr proposed his quantized shell model of the atom to explain how electrons can have stable orbits around the nucleus. So Bohr modified the Rutherford model by requiring that the electrons move in orbits of fixed size and energy. So the energy of an electron depends on the size, okay, of the orbit and is lower to smaller orbits. As you can see, the radiation can occur only when the electrons jump from one orbit to another. So the atom will be completely stable in the state with smallest orbit since there is no orbit of lower energy into which the electron can be jumped. So here is the Bohr's model of the atom. Ito yung illustration. Ano? So, sabi, sa Bohr's model of the atom, according to it, Bohr's model consists of a small nucleus or what we call positively charged, okay, surrounded by negative electrons moving around the nucleus in orbits. Ayun yung Bohr's model of the atom. So in an atom, electrons or negatively charged revolve around the positively charged nucleus in a definite circular path, which is what we call orbits or shell. So, ilan lang yan doon sa mga nabanggit na laws ng Bohr's model of the atom. So, let us now proceed with the Sommerfield's model of the atom, which has been proposed in the year 1916. Ano? So, ito yung pinakang illustration niya. Yan. So, the German physicist Arnold Sommerfeld postulated that electrons can be followed elliptical. Meaning to say, yung galaw niya is elliptical. Okay? So, meaning to say, from his postulations, sabi niya, that electrons can be followed elliptical rather than a purely circular paths and other introducing a new quantum number, ang tawag natin azimutal or azimutal rather, quantum number to account for angular momentum. So this model explains the fine spectrum of hydrogen atom. Okay? And here are the important postulates of Summerfield atomic model. Number one na nito is the orbit can be circular or maybe both circular or elliptical. Then, when a path is elliptical, then there are two axes, major axis and minor axis. When the length of major and minor axis becomes equal, then the orbit is circular. Okay? So, number three explanations ng Summerfield's model of the atom. The angular momentum of electron moving in an elliptical orbit is, okay, kilometer per hour to 2-hour axis. Okay? So, yung pinakang niya, yung length niya is minor axis. Okay? So, yung pinakang value niya is yung K. Ano ba yung K na tinatawag? So, ellipticity of the orbit decrease when the kinetic, okay, or n is equals to kinetic, then orbit is circular. So, Sommerfeld suggested that the orbit are made up of sub-energy levels, and these are S, P, T, and L. These subshells possess highly or slightly different energy. Okay. So, ilan lang po yun sa mga nabanggit. Okay? Sa mga nabanggit na atomic model. So, sabi dito that the atomic mass and atomic number, yan. So, atomic mass and atomic number, today we know that atomic number gives the number of protons or positive charge in the nucleus. So, this was discovered, or this was the discovery made by Henry Wayne Jeffreys mostly. Okay? So, he found that certain lines in X-ray spectrum, each element move the same amount each time you increase the atomic number by 1. So, pag sinabi nating atomic number, it is also known as proton number. Okay? Tatandaan nyo, pag sinabing atomic number, guys, it is also called as proton number. So, it refers to the number of proton, okay, number in a nucleus of each atom of an element. In neutral atom, proton is equal to electron number. So, kung titingnan nyo sa illustration, ipinapakita dito that these are the different, or these are the parts ng isang element. Yung sa element natin. Kung titingnan nyo siya sa periodic table of element, yung nasa taas is the atomic number, yung nasa gitna, yung symbol, okay? Yung, itong sodium, it is the element name, and then nasa baba is the average atomic mass. Yan. So, atoms of each element contain a characteristic, okay? So, it contains a characteristic number of protons. And in fact, the number of protons determine what atom we are looking at. Okay? So, example, all atoms with 6 protons are carbon atoms. So, the number of protons in an atom, okay, is called the atomic number. Guys, kapag hanapin natin itong number na to, okay, o halimbawa ibinigay sa inyo itong number na to, usually, ito yung ginagamit natin para hanapin kung anong klase ng element siya. Halimbawa sa number 1. Ang number 1 atomic number ay katumbas ng hydrogen. Okay? So, doon lang siya naglalaro. So, meaning to say, in every number of atom or in every atomic number, yun yung hahanapin mo o titingnan mo para malaman kung ano ang element ito. Let's say ito, 11, the atomic number. Okay? Pag tinignan mo yung 11, makikita mo kung ano yung element na yun. Anong klase ng element meron sa kanya, sa number 11. Okay? It is because that is also the number of protons na meron doon sa element na nabanggit. Okay? So, forms of the same atom that differ only in their number of neutrons are what we call the isotopes. Again, forms of the same atom that differ only in their number of neutrons are called isotopes. Okay? So, as you can see here, okay, that and the atomic number and atomic mass sa table 2, okay, as you can see, okay, that here is the symbol. Let's say we have I, that is the element symbol. Then, ang kanyang element name is iodine. Okay? So, yung average atomic mass niya is 127. Yung kanyang Z or atomic number is 53. Same with its number of proton, 53. Its number of electron is 53 at ang kanyang neutron ay 74. Okay? So later on, mapag-aaralan natin paano po ba nakukuha yung number of neutron. Okay? So later, makikita natin siya. Next, we have here Cr plus 2, which is chromium or chromius ion. This chromius ion is composed of average atomic mass 51, okay? Ang kanyang atomic number is 24, same with its proton. Ang electron niya ay 22 at ang kanyang neutron ay 28. Okay? So, yun namang oxygen 2 is oxygen or oxide, which has an atomic number, average mass, which is 16. Ang kanyang atomic number is 8, which ang proton niya ay 8, while yung kanyang electron ay 10 at ang kanyang neutron ay 8. So sabi dito guys, an atom have different properties based on the arrangement and number of their particles. So before we delve into how 118 elements in the periodic table were formed, let's familiarize with the following radioactive particles. Kasi sila ay involved dun sa tinatawag nating nuclear reaction. Okay, so ano-ano daw po yun? Number 1 po, or letter A is fusion, and then letter B is fission. Guys, pag sinabi nating fusion, two nuclei are combined. While sa fission naman, ito naman yung split, okay? Or splitting of two smaller nuclei. Okay? Again, ulitin ni Ma. Guys, pag sinabi nating fusion, it means it is a combination. To make it simple, combination of nucleus. Okay? While yung fission naman is the splitting of nucleus or nuclei. Okay? So, these two reactions are processes involving the emission of energetic particles of an atom. Ang tawag naman natin doon, sa reaction na yan, is radioactivity. Okay? So, pag sinabi natin radioactivity again, is the process that involves the emission of energetic particles of an atom. Again, pag sinabi natin radioactivity, it is the process involving the emission of energetic particles of an atom. So here are the most common type of nuclear reaction. Okay? We will proceed now with the most common type of nuclear reaction, which is number 1 is the alpha decay. Okay? Pag sinabi nating alpha decay, it is a high-speed particle that is consisting of 2 protons and 2 neutrons. Okay? These 2 protons and 2 neutrons lost. Okay? An atomic number down by 2 and atomic number or atomic mass is down by 4. Okay? Yun yung alpha decay. Pag sinabi nating beta decay, ito naman yung tinatawag na high-speed electron. Again, ulitin natin, alpha decay po is high-speed particle consisting of 2 protons and 2 neutrons. Yung beta decay po is high-speed electron which is containing, okay, it contains one neutron that turns into proton. Okay? And then number 3 is the gamma radiation. Okay? Pag sinabi natin gamma radiation, guys, it is a high energy stream of protons or photons. Okay? Which is a bundle of electromagnetic energy that is a basic unit that makes up all light. Yung photon na tinatawag. So due to a high energy nucleus, energy is given off and nucleus become stable. Okay? Number 4 is the positron emission. So pag sinabi natin positron emission, it is a positively charged electron in which one proton turns into a neutron and atomic number is down by 1. Yan. Then number 5, electron capture. Guys, pag sinabi natin electron capture, it is a drawing of an electron into an atom's nucleus. Number 6 is the bombardment rather of alpha particle. Pag sinabi natin bombardment of alpha particle, ito yung addition of alpha particles. And number 7 is the proton. Pag sinabi natin proton, it means positive charge. And neutron has no charge or what we call uncharged. Okay? So, that is our lesson in module number 3.